So these notes were titled literal equations, and we said, what is a literal equation? It's an equation that has two or more different variables. A literal equation is an equation that has two or more different variables. So as you can see in the problems 1 through 4 here, we have equations that have an m and an n. And the directions say solve each equation for m. That means we want to get m by itself. Then find the value of m for each value of n. So I said if n is, and in each of the problems it's a little bit different, okay? I think that most people started struggling with number 3. So number 3 is the problem that I'm going to do with you. Now maybe you already have number 3 done and you just kind of want to check it as we're doing it, and that would be fine. So again, the first thing that I want to do is get m by itself. And right now the m is on the right-hand side of my equation. So I'm going to rewrite this as 4m plus 8 equals negative 5n. I just flip-flop sides. I didn't change anything, okay? But my m at least now is on the left-hand side, which is nice. Now I'm going to get rid of this 8 by subtracting it from both sides. So that gives me 4m equals, and I can't subtract 8 from 5n because they're different terms. They're not like terms. So it's just going to be negative 5n minus 8. And lastly, I'm going to divide by 4. And over here, I need to divide both of these terms by 4. So that gives me m equals negative 5 over 4n, and then negative 8 divided by 4 is a negative 2. So this is the equation that we're going to use when we start going over here substituting in for the n. I'm going to switch colors to make it a little less confusing. Alright, so I want to figure out what is m if n is negative 1. So I'm going to go over here and I'm going to say negative 5 over 4 times negative 1 minus 2. So again, I'm just substituting in for the letter n. Okay? So negative times a negative is a positive, and I know that 5/4 times 1 is 5/4. So I get 5/4 minus 2. And this is where some people really started struggling. If you are doing 5/4 minus a whole number, we need to write this whole number as a fraction. So to make a whole number into a fraction, you put it over 1. And in order to add or subtract fractions, we need common denominators. So if 5/4 has a denominator of 4, I need to make it so that 2 over 1 has a denominator of 4, which means I'm multiplying by 4. So it becomes 8 over 4. So 2 changed to 8 over 4. So now I can do 5 minus 8, which is negative 3 over 4. Okay? Now, I don't want you to erase anything on your paper, but I need to write bigger up here, so I'm going to erase this side so I have more space. Because now I need to do, what if n is 0? So negative 5/4 times 0 minus 2. Right. So 0 times anything is 0, correct? So 0 minus 2 is negative 2. All right? And lastly, I'm going to do negative 5/4 times 1 minus 2. Well, we know anything times 1 is just itself, so negative 5/4 minus 2. And now we kind of have the same issue going on that we had over there. We need to write 2 as a fraction, which would be 2 over 1. We need to make it common denominators, so I'm going to rewrite my 2 as 8 over 4. Alright, so now that we have this, we're doing negative 5 minus 8, which is negative 13 over 4. 4 goes into 13 3 times, so that's going to be a negative 3 and 1/4. I told you to leave it in proper. You can leave it in proper. That is fine. You may leave it in proper. Okay? That would be fine. You can also, on any of these, you could have changed 5/4 into a decimal. 5/4 would be 1.25. So you could have done a negative 1.25 times 0, a negative 1.25 times 1, a negative 1.25 times negative 1. And that might have helped you as well. So you don't have to leave things as fractions. You can change things into decimal form. And that might help you with number 4 if you do that one. All right, let's look now at the next section. And in the next section, you have these literal equations with a lot of different variables. But we want to get in all of these equations the x by itself. The x by itself. So some of these we did problems that were almost identical to them in the notes yesterday. And I know, again, I wasn't able to record those notes yesterday, but hopefully you could maybe look at some ones if you weren't here physically or mentally, maybe not here. Get it? But of these 6, to me, they're all kind of this, like, the same level of difficulty. So is there one of these, as you were working on them, Dawson, that you think is the most challenging? All right, let's look at number 9 then. I'm going to blow this up some. All right, so in number 9, here's this x, okay? We want that by itself, so everything else we have to move or get rid of. So the first thing that I'm going to get rid of is dividing by y plus 2. So the opposite of dividing is multiplying. So that means if I multiply both sides by y plus 2, then that's gone. So I have x minus 4 equals 5 times y plus 2. Very good. The next thing that you should do is go ahead and distribute your 5. 5 times y, 5 times 2. So that's going to give me x minus 4 equals 5y plus 10. And now I can get rid of this minus 4 by adding 4. And I only need to add 4 one time over here on the right. And I do have a constant over here that I can add it to. So it's going to be x equals 5y plus 14. I'll pause the video so people can. Now, on the back side of your paper, numbers 11 through 16 are similar to the ones I just worked on, but they're more difficult, okay? So let's look on the back. Again, 11 through 16 on the back, same idea. There is a variable that they tell you that they want you to get by itself. Okay, so like number 11, they want you to get the n by itself. So you have to really pay attention to what they're wanting you to get by itself. Now, again, these are more difficult. I will do 2 of these with you. Calvin wants number 12. All right, well, we'll do 12 and then look over the others and then we'll take a vote. All right, so let's look at 12. All right, number 12. We want to get C by itself. So here's the first thing I want to do is, like, where is C? All right, there it is. And that's the only one in this equation. That's the only C. So that's nice, and then it's already on the left. If it wasn't on the left, then I would flip-flop sides. Okay? So, next, I need to, just like solving an equation, you kind of do reverse order of operations. I don't want to get rid of this D first. I'm going to get rid of this 2 first. So I'm going to subtract 2 from both sides. And when I do that, I get C divided by D equals, now I can't subtract 2 from F divided by G. Those are not like terms. So it's just going to be F divided by G minus 2. Not yet. Because remember, I want C by itself, and right now C is not by itself. So next I need to multiply by D. So I'm multiplying this whole thing by D. Distributive property right there. So how do you do that? Well, let's look. So I get C by itself. That's good. So I'm going to do D times F over G. Now, technically, if I was going to write D as a fraction, wouldn't it be D over 1? And if I had, I'm going to write this over here. If I had D over 1 times F over G, isn't it when you multiply fractions that you just multiply straight across? So wouldn't this be df over g? 1g, but we don't need that 1 there. So d times f over g is df over g, and then a negative 2 times d is negative 2d. And there it is. I'm going to pause the video for a second. I'll do 16. I'll do 16. I'll do 16. 16, you have to do that reverse distributive property. Anyone still writing this part? Good? Yeah, writing? No writing, or yeah writing? No. Okay. No, oh, I do. I'll be here without you. Alright, we are ready. So in number 16 says that you want to get D by itself, and right now D is right there. So one thing that I don't like is that D is on the right hand side of my equation, so I'm just going to take a second and rewrite this so that everything that's over there on the right is on the left. 1/2 BCD plus BC, and then the A is going to be going on the right. Alright? This is a formula for finding something, the area of something. So that's why. So it's not a lowercase a like these other variables are. Okay. The next thing that I'm going to focus on is getting rid of... I'm going to pause for a second again. Next thing that I want to do is I'm going to go ahead and get rid of this plus BC. So I'm going to subtract BC. Oops, sorry. I'm going to subtract BC from both sides. So that's gone. And that's going to leave me with 1/2 BCD equals A minus BC. I'm not going to erase anything. Now, I'm going to say, I want to get rid of that 1/2. To get rid of 1/2, you can multiply by 2. When we, okay, we'll put it this way. To get rid of multiplying, you divide. 1/2 divided by 1/2 is the same thing as 1/2 times 2 over 1, right? Same change flip. So to get rid of this 2, we need to multiply, to get rid of this 1/2, we need to multiply by 2, and multiply by 2 over here also. So, when I multiply this over here by 2, this is gone, leaving me with BCD. And on the other side, when I multiply by 2, there again, I can distribute 2 times A, 2 times negative BC. So that's going to give me 2A minus 2BC. Almost done. Now I want to get rid of multiplying. Remember, I want D by itself. So I need to get rid of multiplying by BC, so I can divide by BC. Divide by BC. These are gone. And I'm left finally with D equals 2A minus 2BC over BC. You do this in grade 9. we kind of talk on this bottom section why we're actually doing this, why we actually want to isolate a variable, okay? These are actual problems where you're finding either perimeter or area or circumference of a shape where you have those formulas, okay? And they don't, normally if I want you to find like area of a circle, I give you the radius and you find the area. But sometimes I give you the area and I want you to find the radius, okay? So if we isolate the variable for that, then we can find it more easily. So I did go through the formulas for these things, whether it was perimeter or area or circumference. I gave you those formulas yesterday. But let me give you those formulas just in case. For instance, in number 17, they're talking about area of a rectangle. So you're going to need to use A equals length times width. But you're going to need to get the L by itself, or excuse me, the W by itself. If A equals L times W, what does W equal? Wouldn't that be area divided by length? Yeah. So that's the formula you would use then to find the width. Yes? Yep, that's what I was getting ready to do. So number 18, circumference of a circle. Circumference equals 2 pi r. And it says to use 3.14 for pi. Number 19, the perimeter of a rectangle. Perimeter equals 2 times the length plus 2 times the width. And they want you to get the width, so you have to get the W by itself to solve. Number 20 is the area of a triangle. So area equals 1/2 B times H. Number 21, the circumference of a circle. Again, circumference equals 2 pi r. And 22, the area of a triangle. Area equals 1/2 base times height.